this lesson, I'm going to be discussing the concept of concentration, and specifically the concept of molarity, which is one way of measuring, of quantifying the concentration of solutions. Okay? So the definition or the equation for molarity is that molarity equals the moles of your solute divided by the liters of solution. Okay, so let's really quickly talk about three major concepts for this lesson, which is what exactly is solute, what is your solvent, and then what is your solution. Okay, so to begin with, your solute. Your solute is what is being dissolved, or the substance that is being dissolved. Okay, so for example, if I'm dissolving salt in water, okay, the salt is going to be your solute. A solute can also be a gas. So the fact that when you're drinking bubbly water, it's because there's carbon dioxide that is dissolved in the water. Carbon dioxide in that case is your solute. Your solvent is going to be the substance that does the dissolving. So in this case, it would be water. And then finally, your solution is going to be your solute and your solvent together. So in my example, it would be salt as the solute, water as the solvent, and then your solution is simply salt water. Okay? One last thing to talk about, units for molarity. So while molarity is one measure of concentration, its units are a capital M, and we pronounce that molar. Okay, so the higher your concentration, the larger your molarity will be. So for example, a 6 molar solution is much more concentrated than a 1 molar solution. Okay, let's look at 3 problems that have you use molarity. All right, for this first one, it says determine the concentration of copper chloride solution that has a volume of 450 mils that was created by adding 5.67 grams of copper chloride. So remember, molarity is your moles of your solute divided by your liters of solution. Okay, so for this problem, my solute is the 5.67 grams. But I can't plug that into my molarity formula yet because I am in grams and I need to be in moles. So I'm going to first convert out of grams, get myself into moles. Okay, and to do that, grams to moles, that is my molar mass. So I need to take the molar mass of copper, which is 63.546, and I'm going to add to that the molar mass of chlorine, which is 35.453, multiply that by 2, and I get my molar mass of 134.452. And I get my molar mass of 134.452 grams for every 1 mole. Okay? And so I'm going to take 5.67 and I'm going to divide it by that molar mass, and the value I get, I'm going to round it when I write it here, but I'm going to keep it unrounded in my calculator, is this. Okay? So I now know my number of moles. Great. But now I need to figure out my volume in liters. Okay? So I have 450 mils. If you can do this in your head and recognize that to go from mils to liters, you simply have to divide by 1,000 and move your decimal place over 1, 2, 3 places, awesome, good for you. You don't have to show your work. But if you're a little bit unsure of this still, that's fine. I'm going to put mils on bottom, liters up top. I know that 1 mil is 10 to the negative 3rd liters. And so that will, again, give me 0.45 liters. Okay, so now I'm going to plug in all of my values. My molarity equals my moles, 0.4217, divided by my volume, which is 0.45 liters. Okay, and so what I end up getting for my molarity, unrounded, is 0.0937. And my units are going to be molar. Now I have to quickly figure out my sig figs. Okay, so 450 mils has 2 sig figs. 5.67 has 1, 2, 3 sig figs. So this is going to be 2 sig figs. So my final answer is going to be 0.094, and my units are molar. Okay. Let's look at the next problem. For the next problem, it says how many grams of solute are in 3.00 molar solution of potassium nitrate that has a volume of 2.52 liters. So again, remember molarity equals moles of your solute divided by liters of your solution. In this case, I know my molarity is 3.00. Okay. I don't know my number of moles, so that's going to be my X, and I know my volume is 2.52 liters. So to determine my number of moles first and then figure out my grams, I have to multiply 3 by 2.52, and I get 7.56 moles. Okay, now that's moles, that's great, but I don't want to be in moles, I want to be in grams, because that's what it's asking about. So I'm going to get out of moles, and I'm going to get into grams. Now remember, to go from moles to grams, I need to use the molar mass of potassium nitrate. Well, the molar mass of potassium is 39.098. The molar mass of nitrogen is 14.007. Okay? And the molar mass of oxygen is 15.999 times 3, because I have 3 oxygens. So the molar mass of potassium nitrate is 101.102 grams for every 1 mole. So now I'm going to take 7.56, I'm going to multiply it by the molar mass, and the unrounded value that I get is 764.33. Let's look back at my values that are given to me. 3.00 has 3 sig figs. 2.52 has 3 sig figs. So this needs to have 3 sig figs. So my final answer is going to be 764, and my units are grams. So 764 grams of potassium nitrate had to be added to enough water to get a volume of 2.52 liters to create a solution that had a concentration of 3.00 molar. All right, let's look at one last problem. How many liters of a 0.500 molar sucrose solution contain 1.5 kilograms of sucrose? So here's my concentration. Here's my mass. Remember, molarity equals moles of solute divided by your liters of solution. So I know my concentration in this problem is 0.500 molar. Okay? The other piece of information that I know is how much solute I have. I have 1.5 kilograms. But the problem is I need that in moles. So I'm going to first have to convert this into grams, because then from grams I can get into moles. Okay? So 1 kilogram is 10 to the 3rd grams. Grams to mole conversion, that is my molar mass. So I'm going to take the molar mass of carbon, 12.011, multiply by 12. Add to that the molar mass of hydrogen, 1.008 times 22. Add to that the molar mass of oxygen, 15.999 times 11. And I get, for the molar mass of sucrose, 342.297. Okay? And that's grams for every 1 mole. So I'm going to take 1.5, multiply by 1,000, divide by my molar mass, and that will be my number of moles that I'm going to plug in here. So 4.3, and I'm going to keep this, I'm going to round this to write it on the page, but I'm going to keep it unrounded in my calculator. And then I'm going to be solving for x. Okay? So this is the one mathematical thing that students really have a hard time with, solving for a variable when it's in the denominator. Remember, if you're ever given a fraction with an equal sign, all you have to do to solve for an unknown is cross multiply. So this is going to be 0.500x equals 4.38216 times 1, which is just 4.38216. So hopefully you didn't take out the 4.38216, etc., from your calculator, because then all you need to do to solve for x is divide it by 0.5. Okay? And that will end up giving you your volume in liters. So I'm going to divide by 0.500. And my volume in liters is going to be, I'm going to keep this unrounded for a minute, 7,643. Okay, so I want 1, 2, 3 sig figs or 1, 2 sig figs. So I want a total of 2 sig figs. So this is going to round to 8.8. And my units, because your units for your volume of your solution is going to be liters. Okay? And that's all there is to it.